First of all, I convey my sincere thanks to the organizing committee of this MEPCO Engineering College for having this wonderful 6 days FTP on management information system. And being this sixth day, I would like to share some of the concept and some of the things related to the latent in semantic indexing. So we have traveled this 5 days and the 6 days. This is 6 days. We have traveled for this last 5 days in the context of this information retrieval, and in continuation with that, we will move the next title of this today's workshop, that is a latent semantic indexing. Okay. Yes. So in this information retrieval context, this latent semantic indexing is one of the techniques used in 3 different domains. First one, mainly it is in search engines for information retrieval. At the same time, in the business era, it is used for in the field of search engine optimization. So this is one field. So in the term of this information retrieval, this is used in the search engine, and also for the search engine optimizations, this technique considered as one of the major role. And second one, in machine learning, it is used in natural language processing for identifying the text and the context of that particular text and the documents. So it is used in natural language processing. And the third one, it is used in some of most of the medical domains to analyze the context of the behaviors of these genes. So in these three things, we will go through this techniques in the view of the information retrieval. Okay, we will move on. So before, as I told you, this latent semantic indexing will be plays a major role in search engine. Just for the idea of that search engine, we'll see the topmost and the top 5 search engine of the 2020. In fifth one, it is Yandex. This is the search engine. It has the worldwide search engine market share as 1.53%. If you take a complete worldwide, if you are doing a search by using a Yandex search engine tool, around 100%, 1.53% people are using this Yandex search implemented and dominated most of the Russian search engine traffic. So mostly 55% of the total Russian populations are using this search engine tool. Say this is being in top 5th position, and this search engine market share is 1.53 out of 100, I'm telling you. And if you go to the fourth one, we have a search engine called Yahoo. We know this company familiar, and it has the worldwide search engine market share as 3.39%. It is in 4th position of worldwide. Its search engine is now currently it's powered by the Bing search engine, which is owned by the Microsoft. This is the fourth one. If you go to the third one, this is Baidu search engine, mainly used in the Chinese people. In this is the China's largest search engine tool. It is in this. It has 7.34% of worldwide search engine market share. So this will be, the culture in this China, the informations and the privacy is very important. Say they are not allowing any other search engine tool. So in that situation itself, it has that much shares, then this considered as a top 3. In top 2, we know this Bing. This is worldwide search engine market share. It is 8.04%. It is owned by and operated by the Microsoft. So we know this is out of these 5, we know which one is in top. Yes, obviously the Google search engine tool is in top by providing information, and for the information retrieval for the users, it's being a topmost positions in the recent year. In an overall search engine market share, it has 92.18%. You may compare this market share with the previous all 4 search engines. You may find out the difference between the other search engine and the topmost search engine tool, this Google. In addition with that, we have another search engine tool like Ask, and DuckDuckGo and Naver, which is South Korea, and AOL, American online search engine tools. These are all the, again, next to fifth positions, these are all the search engine tools which is dominated in that particular region. But overall, top is the Google search engines. Why we are looking at all these search engine tools, and there is a concept behind in this search engine tools that is called latent semantic indexing. So before we move to this title, we'll look it out. Just a minute. Yeah, just we'll do some search in by using our Google search engine tool. Just I type food. We'll change this result into images, then only for our understanding purpose. So if I type food, it gives you a result of all topmost food. And if I type hot food, it will give you some of the results of this of the food. So we may get these kinds of results. The food and the food are related to hot, and we'll type spicy. All the spicy food items. Of course, in the spicy food item, on topmost result, we are having this red chili. Actually, this is not a food item. Now we could understand a little bit context in the word. So if I type, the food is for the, especially for chicken. These are all the food related to the chicken. Okay. So likewise, if I try to find out the food fish, this is not what we expect, right? So this is a food is given to the fish which we are having as a pet, and fish tank and aquarium. So this is the food. So when we are typing in our text, we have a different context when we are typing the text. Also, we expect the result from the search engine that it has to understand our text and also the context behind the text, and it has to give such a proper result what we have typed. And this is one thing. So when we are typing and when we are trying to getting a result, when we are trying to retrieve some information, we are expecting that particular tool. It may be a search engine or whatever it may be, which will give the result of the information retrieval. We expect that has to understand the context, and that has to understand the relations, and that has to understand what we are thinking when we are entering into this keyword. And now, if I am trying to find out, so I want to show the apple fruit to my little bit daughter, who is having 2 years old or 3 years old. She doesn't know what is apple, so I'll try to look it or show apple to her. So if I type there, so in the topmost result, I'll get the result of the Apple company logo. So what I actually want, this is apple as a fruit. So as a user, we cannot expect the all users, those who are getting a result or those who are trying to get a result, they should know with proper context of whatever we are typing. That's why we are all of us, we are having a smartphone. In our smartphone, if we are typing in a fast, we expect that smartphone should automatically correct the contents, even the spelling is wrong. So that itself, we are expecting the system or the mobile phone has to be corrected by itself, whatever we are typing it related to that word or the spelling of that word. So if we couldn't expect, we are typing the same, the word with the context. So this is called synonymy. That means, polysemy. This is, we have a single word, but it gives a different meaning. So would be represented as a company, and apple would be represented as a fruit also. So this is another issue when we are typing or when we are trying to retrieve an information from the search engine or whatever the information retrieval tool. Next, one more example. Initially, we have seen the context to be understood by the system, and second one, the polysemy. That means for the single word we have a different meaning. That's that concept called that is called the polysemy. That has to be understood by the system. And one more thing is, if I am typing, I'm having an automobile industry and I'm running a car automobile. So if I type automobile, because from my experience, whatever we are having in my surrounding, we could pronounce that a car as an automobile, or we could pronounce that car as a vehicle. So if I type for vehicle or automobile, I expect the result comes as a car, right? So in overall throughout the world in automobile industry, the cars leads the topmost. So even I didn't type this keyword as a car. So when I type the automobile, I didn't get about the bus, I didn't get about the other vehicles, but I get the images of the car. So this is called as a synonymy, which has the same meaning but different words. Type car. If I type automobile, again I'll get the images of car. So we have a two different keyword, but the meaning is same. So to address these three major issues, we are and the search engine tools are using the concept called latent semantic indexing. So if I type a keyword search that is called umbrella in photography. So this is the photography I'm running on photography. Photoshop and running a photography. I'm doing a photography. So I want to purchase the umbrella which is used for the taking a photos, shooting of photos. So when I type the umbrella in photography, so I should get the result of the umbrella reflector, then the soft boxes which is related to that umbrella, and light modifiers which is related to this umbrella or the photo shoots. But I should not get like if I have a keyword called umbrella, but I should not get like a rain and thunderstorm and showers and etc. So this context has to be understood. We expect as a user that the system has to understand this context. For that only we are using this latent semantic indexing. So this latent is, it means the features that are hidden in the data. When we are typing the data, the features and the meanings are hidden, which cannot be directly measured. See, if I type automobile, I cannot say that the automobile means car. There is no direct measures. So that features is hidden in when we are typing the automobile word itself. The features is hidden. That is, the car is also an automobile. So that these features are essential to the data, but not original features of the data set. So I type the automobile is the original features. Automobile is the original keyword, but it relates the like car or lorry or truck or whatever. So it comes. So this latent has to be indexed when we are typing or when we are handling the data in the information retrieval portions. So what is exactly this latent semantic indexing means? It is an indexing and retrieval method that is used in a mathematical technique called singular value decomposition, in short SVD. So by doing this latent semantic indexing, in this technique we are using a statistical technique called singular value decomposition to identify the patterns and the relationship between the term and concept. So if you are typing a apple, food, fish and automobile, all are term. So if I type automobile, the car, the relationship between the automobile and car is a concept. If I type fish food, the relation between the fish and food, and there is a recipe, there is a concept. So by identifying the relationship between the term what we are typing and the concept what is behind latent in that concept, that is to be considered in that unstructured collection of text. I repeat this concept once again. So this latent semantic indexing is the indexing and retrieval methods that uses a mathematical technique that is singular value decomposition. This is a technique, just we'll touch this technique in outline only. We cannot go in deep. So it has some set of calculations. Just we'll know how this latent semantic indexing are working and how this SVD is used in this LSA. So why we are using this? To identify the features and the concept behind the term or what the document between the documents. So it mainly has to understand the context of the content. Describe the process that search engine algorithms, whatever the algorithms are used in the search engine, that used to understand the context of the user's content. So whatever the data or whatever the keyword is typed or entered by the users, the context and the relationship between keywords. If they are typing a more number of keywords, then the relationship between the keywords also has to be identified. So mainly these we have a main many number of documents. We have a document A and we have a document B. Any word with each other. So A is a separate document and B is a separate document. But both share a lot of words.
Professor Vinoth Kumar, sir.
So A and B doesn't.
Sir, sorry for disturbance, Professor Vinoth Kumar, sir.
Yes, sir. Tell me, sir.
Sir, some disturbance, some noise is inside your side, sir. Actually, so.
Just a minute,
no. Yeah. Please correct it, sir. Please correct it.
Is it so? A disturbance in the sense, are you getting any noise or?
Noise, sir. Noise. Some sound is coming behind nearby your place.
Okay. Fine.
Whether it's the window closed or not, sir. Whether the window is closed or not.
Yes, sir. It's closed only.
Yeah, go. No problem. Okay, sir. Focus, sir, please.
So we have a different documents. In this documents, we have a document A and B and like C. So A documents has a set of words and each other. It has words each other, but it doesn't have the sharing any words with A and B. But we have another document C, but A and B shares a lot of words with document C. So if you look at the document only A and B, we could come to the conclusion that A and B doesn't have any relations. But if we have one more document C, then both A and B connects to the document C. Then we come to know that the A and B will be considered as a similar documents, or there is some relation between the document A and B. So the latent semantic indexing has to identify two important things. One is the context of the content, whatever we are typing, and the relationship between the keywords. For example, so when we are typing a Google search engine, when we are typing any result like photography, umbrella in photography, or fish food or fish recipes, when just for understanding only, we have gone through the images. For the web links, we could get many documents, we could get many web pages. That each web pages will be considered as a document in information retrieval context. So when we have a more number of documents, so we are trying to retrieve documents with the context from the information retrieval portal. So we have a document 1. In this document 1, we have Romeo and Juliet. This is only one keyword in that document. So we have another document D2. In this document, Juliet says, "Oh, happy dagger." This is the document 2. So we have another document D3. So in this document, we have a text called Romeo died by dagger. So this is a 4th document, live free or die. That's a New Hampshire's motto. So this is 4th document. And this is the 5th document. Do you know New Hampshire is in New England? So we have these 5 set of documents in the information portal. So we are trying to retrieve, or we are trying to get the document related to the queries dice and dagger. So from the participant side, anyone could you say which document comes as a first? When we are using this query search query as dice and dagger, which document from D1, D2, D3, D4, D5, from which document will come first as a topmost priority, as topmost rated result? Okay. So here in document one, our search query is dice and taker. So if you look at the document 1D1, it doesn't have any queries. It doesn't have any keyword. If you take D2, it has the query baker. So it will consider that one, and also it continues its search to the document D3. So it has, the document has Romeo died by Daker. So it has the keywords dice and Daker. So this considers the most rated, and it will, with that in the backup, it will continue into the next document D4. So in this D4, it has identified that keyword die. So this is also considered as related to the keyword. And the document D5, so it doesn't have any keywords which has founded with the given query dice and daycare. So it gives a top priority to the keyword D3 that will comes as a first. Then either D2 or D4 will comes as a next. So it may be D3, D2, D4, and then D3, D4, D2. So based on the keyword we are given, this will be considered. But when you take the document D2 and D3, it has the keyword of the document related to the D1. So in D1, it has Romeo and Juliet. In D2, it has the sentence with the Juliet, it's a happy dagger. And in D3, so it has a Romeo died by the dagger. So it will take the keyword from the document D2 and D3, Romeo and Juliet, and it will connect the document D1, and it will gives you the next result as D1. So the D3 will come first, and D4 will come next, or D2 will come next, and then D4, and then D1. Because it doesn't find any keyword, but it will find out the relationship between the documents, so it will find out. Obviously, it comes to D5, so that will comes as a last priority because it doesn't have, it couldn't find any relations. Yeah, of course, there is a relation with document D4, but the weightages is very less. So of course, among these 5 documents, D5 will come at last. So here in this example, it identifies based on the keywords and also the relationship among the documents. So we here up to this we have seen when we are giving a keyword to the search engine and common information retrieval, and we are trying to get an in the data keyword whatever we are giving. So we expect as a user we are trying to get has to understand that text with the context or the meaning and the relationship. We are giving more number of queries. So for that, and the search engine side or the information retrieval side, they are using a concept called the latent semantic analysis, latent semantic indexing to identify the context and the relationship between the data or the text whatever given by the users. So the concept of the latent semantic analysis, when we are giving a raw text data, it's given by the user. So that data will be entered into the latent semantic index. So initially the document or the data, whatever we are given, the data will be separated or prepared as a document term matrix by this latent semantic indexing. So the data, the complete data will be prepared as a document term matrix. And then from that matrix, we will assign the number of weightages to that matrix. And then we are calculating and we are doing a singular value decomposition to reduce the dimensionality of the matrix to get a proper data and to find out the relation among the proper data. So to reduce the dimensionality, we are doing the technique called singular value decomposition. Then we are getting an exact relationship and the context behind the data, and that will be given as a output. That is the topic encoded data to the user. So repeat, from the user side, they will give you a raw text data. That data will be separated and formulated as the document term matrix by the latent semantic analysis or the latent semantic indexing. And then from the document term matrix, the singular value decomposition techniques by using this SVD, the document term matrix will be converted into a lower dimensional set of a matrix or lower set of a dimensional data. And then that will be at last with the weightages of the term and the relationship between each term, it becomes the topic enabled data. So whatever we are typing a raw text data, that based on that data, it enabled with or it will encode the concept related to the data also. So this is just a sympathetic or the pictorial representation of this latent semantic indexing. We'll take one example. So here we have two different concepts. So here the term concept matrix is prepared. So here in this previous slide, you see the document term matrix is there now. So in this we have prepared the term and the concept matrix. So the term, whatever the term or the data we are given as a keyword, concept related to that keyword. So we have prepared a table. This table, we have two concepts. One concept is related to DBMS, that is database management system. The concept is different, that is related to the medical. Okay. So if you take a term or the keyword for that concept, so if you take a database management, we have a keyword or we have a document called database or data system retrieve. We have a keyword or we have a term. And lung and here is a term related to the medical concept. So in this matrix, the row represented the term and the column represented the concept. So we have two concepts, database and the medical. So the term related to the database, it represented as 1, and the term related to the medical, it represented as a 1. So the term lung and ear and the column of the medical concept, so it represented 1. So we have a keyword now, as of now, we have a keyword that's data system retrieval related to the database concept and learn and ear related to the medical concept. So just for an understanding purpose only, we have taken a simple keywords, that means a very minimal keywords, but in real time, it will handle a huge number of terms and the concept related to the terms. So we have one more matrix. This is called document concept matrix. So this term, the data system retrieval, maybe comes from a single document D1, or it may be a different document like D1, D2, D3, D4, etc. Okay. So if we are trying to connect or if we are trying to prepare a matrix of the document and the concept. So the documents, we have a 4 number of documents, that is D1, D2, document 1, 2, 3, 4. Document 1 and 2 related to the database concept, and 3 and 4 related to the medical concept. So we have two different concepts, two different matrix. One is term and concept matrix. It will take a term. It won't consider the number of documents. It will take a terms from the documents. It may be a huge number of terms. Maybe we will see in another example also. So it will take a huge number of terms. Then it will segregate and it will take the concept of the terms. So it will take the database and medical. So like these terms is grouped as a number of documents, also wherever it available. The term, for example, I could say this data could be available, for example only, but could be available in document 1. Or the system and retrieval could be available in document 2. And the lung could be available in document 3, and the earth could be available in document 4. So the number of documents, this document is also huge. The term itself is huge, and the documents also huge. So the number of documents will be segregated. Documents only will be displayed as a result. This entire page or this document only will be displayed as a result. So we have a matrix called document and concept matrix, which will give a number of documents in row, concept, number of concept in column. If I'm trying to find out the keyword called system, simplicity we are taken only two concepts. So if we are finding out the keyword called the system, then from this, the term and concept matrix, it will identify the concept, the keyword or the term called system. So in this first term and concept matrix, it will identify the system, and it will find out the column or the system, the term system related to which concept. So in this, by looking at as a people or as we know the basic idea about the computer science, so we could know this is a database concept. But here in the as per matrix, it will go through. So it will find out the system is related to the database concept. Then it will link to the next matrix, that is the document and concept matrix, and it will connect the document concept, and then it will retrieve the documents which is related to the document concept, and that will be given as a result to the user. I repeat, we have a two matrix, term and concept matrix, and document and concept matrix. In term and concept matrix, we have a number of terms as a rows, and that will be grouped as a concept. We have here in this example, we have two concepts, a database and medical. So if you take the another one, we have a more number of documents. These documents only will be showing as a result to the users. And have a matrix called the document and concept matrix, and we are trying to get a one keyword. We are trying to get a information retrieval for the keyword system. So if you identify the keyword from the matrix, that is term and the concept matrix. If the keyword is found, system is found, then it will find out the corresponding concept from the column. Then it will connect to the matrix of the number of documents between the concept. Based on the concept, whatever the documents are related to that concept database, that will be given as a result. Likewise, if you are trying with a keyword called lung, then it will find out the lung is in the medical concept. So it will connect to the medical concept. So it will display the document D3 and D4 as a result. So again, come back to the previous or the first example. We have these 5 number of documents, D1, D2, D3, D4, D5. Just consider in our system, we have only these 5 number of documents, and we are going to find out the keyword, or we are going to search the keyword, and we are going to find out the related document for the keyword. So then, as per this procedure, the raw text data is these documents. This raw text data, and this has to be converted into the document term matrix. So we are converting this data, the raw text data, into a document term matrix. So in row we have a number of terms, and in column we have a number of documents. So here document D1, D2, D3, D4, and D5, and the terms. So here we have omitted that objectives and that the is, are, like that the connections, all those things we have omitted. We have taken only the main keywords. So here, if you take the document D1, Romeo, Juliet, so it has 2 terms. So if you take D1, only the Romeo and Juliet, it has an enable, that it has the positive value, that is represented as a 1. The all others are 0. Okay. So if you take D2, so in D2 what it is? Juliet, it says for happy beggar. So it will take in D2, if you take D2, it gives 1, a Juliet, and a happy 1, and beggar 1, and all others 0. Likewise, we are converting this raw text data into a term document matrix. Why we need to convert this? We have to get the result of the given term or the documents with the context, and also we have to identify the relationship among the documents when we are searching the data. Then only we could get the proper result to the user. After this document terms, the term and the document matrix, we are trying to apply the concept called SVD. This is singular value decomposition. So like this, we have one more term document matrix. So here we have a document related to net surfing and the document related to beach surfing. So usually when we are working in the internet or web, we could say that I'm surfing the web, I'm surfing in the internet, like that. Actually, the surfing in the sense we are doing doing surfing in the beach, okay, in sea. So that is actually the beach surfing. If you say that, so that keyword and the term, the context is used in the internet surfing also. So if you take the document D1, what it represents? Obviously, the document D1 relates to the internet surfing. That is, we are working on the internet. So we have a different keyword. Already I told you that synonymy. That is, we have a different keyword with the same meaning. Internet and web both are same. So we have a keyword internet and web surfing. So the document 1 will represent the working on the internet or working on the net. But the document 5 is represent on the document 5. It tells the enjoying this beach surfing. And document 6 it tells enjoying the beach surfing. So if you take D3, that is also web surfing. So it's enjoying in this net. We are working in this net. And document D2, that is internet surfing. So we are working on the net. What about document D4? So it has a web surfing and beach. But compare with beach surfing and net and internet surfing, it has the strong keyword related to internet. So it will give a priorities to the net surfing only. So working on the net. So these are all two examples that we have to convert this raw text data into a document term matrix. So here we have one example, that is Romeo Juliet. We have converted this into document term matrix. Have another example of web surfing and beach surfing. We have converted this document into a next, a little bit technical. That is, after this document term matrix, we will apply the statistical techniques called singular value decomposition on this. So actually, in the machine learning context, it is related. It is related to the principal component analysis, that is PCA in the machine learnings. Actually, why we are using it? When simply we are converting that entire document into a term document matrix, then that matrix dimensionality will be huge. The matrix dimensionality, because simply we are assigning a weightage. See, so we are assigning if it is available in the document, we are assigning 1, otherwise 0. If it's available in more number of times, then based on the number of times we are assigning 1 or 2 or 3 or 4, if it is not there in that particular document, we are assigning 0. By representing this, if you are creating a document term matrix, then the matrix dimensionality of the matrix, if you imagine, that will be huge, and also it is complicated to working on that term. So we are trying to reduce the dimensions of the original data by encoding it using its latent features. So we have to identify the latent features in these terms. So by encoding that latent features with the data, then the document dimensions of that matrix will be reduced. With that latent semantic analysis, these latent features represent or linked to the topics and the original text data. So I'll repeat this concept again. I'll repeat this slide again. So we have converted that into a document term matrix. When we are converted into the document term matrix, the dimensionality will be huge, because simply we are assigning, it's light weighted. So we are assigning the values based on the occurrence. So here, there, the relation will not be there, the latent will not be there, the context will not be there. So based on the availability and based on the occurrence, simply we fixed it. But if we apply this SPD techniques, and there are some calculations by TF and IDF, that is a term frequency and the inverse document frequency, by using that calculations, we can find out and we can reduce the dimensions of the original data by identifying and encoding the features, that is latent features of that particular term or that particular document. Or represent topics that is in the original text data. So we'll go in depth. So this is the definitions of the singular value decompositions. So based on these definitions, if you take any term that can be m into n, if you take any term that can be split into 3 different matrices. That can be split into 3 different matrix terms. That is term matrix. So this is the definitions of the singular value decompositions. So in these pictures, just leave the formula, go to the pictures. If you take the pictures, so we have a m by n document terms. So we have that m by n document terms. So here, this is terms and the number of documents, and this is terms and the number of documents. So these terms and documents, this n documents with m terms, can be split into 3 units. This first one is that can be split as that U, actually that can be split into n documents, n number of documents, and r number of concepts. So here we are telling this is a rank. Okay, so that can be split as the n number of documents with r number of concepts. And written, that can be split as term concept, as we have already seen. The first one we have seen document concept, and another one we have seen term concept. See, what is this? This is the term concept, and another one is document concept. So we are coming back to this diagram. So this can be the any kind of a document, any kind of a documents. If you take any raw text or documents, that can be split as three. First one is a document and concept, that is n documents, n number of documents, r number of concept. If you come to the right end, this is r number of concept and m number of terms. So in a row we have a number of concepts, that is column we have a number of terms. Okay, this is okay. What is in the middle? So we have to find out the diagonal matrix. This is very important. This only gives you a relations, and this only find out the content of the latent of this particular terms. So this diagonal matrix, by using eigenvector and eigenvalues, it will gives you the strength. It will gives you the concept strength, but this should be a diagonal entries. That means it should be R by R. So concept matrix. So mostly in all kind of documents can be splitted like this. So once we are splitted like this, then by using TF-IDF calculations, we can assign and we can find out the concept of the related or the strength of weightages of the related documents. So the A, if you take A, that is n by m matrix, that is n documents and m term. And in right hand side, it can be split as three. First one is U matrix, that is n documents and R concept. Another one is a delta is R and R. This is a diagonal matrix, and it will find out the strength of the each concept. And B is another matrix. It is m terms, m number of terms, and R number of concept. This is the definition of the singular value decomposition. And these are some of the properties and in singular value decompositions. Based on these properties, yes, if you take a matrix A, this matrix can be splitted as U, this alpha and B. So this V could be an identity matrix. So this U, the inverse of the U and U could be identical, and B and B could be identical. So this alpha will be a diagonal matrix, and these three properties will be applied to any kind of a document and terms matrix. We are taking that example. What is this? Here we have this data related to the computers and data related to the medical. So we have seen in this previous example database concept and medical concept. Okay. What I told, in the raw data will be converted into a document term matrix, and this in this document term matrix we are applying this SVD. This SVD we are finding out, or we are reducing the dimensions of the entire data, and also we could find out the latent concept of the particular term can be embedded by using SVD. So if you go through this SVD in detail, we are calculating these weightages by using eigenvectors and eigenvalues, and also this TF-IDF, that is term frequency and inverse document frequency conversions. So the value, if you look it up the left side, from the left side, so the document term matrix, we have the document that is computer science documents, CS documents, and medical domain documents, that is MD documents. In computer science, we have a term that is data, information, info, and retrieval. In medical, we have a brain and learn. If you see the weightages, if you see the weightages, document wise, you look it out. So if you look it out, the document D1, that is first document, it has very limited keyword under computer science. That means it has only one number of data and one information and one retrieval. You come to the next document, it has two 2, 2. So weight is a little bit high the compare with the first one. If you take the third one, the first one and the third one both are equal. If you take the fourth one, it has huge. So it has more number of weightages. It has more number of occurrences in the computer science domain. Likewise, if you come to the medical data, we have 2 and 2, brain and lung, and 3 and 3. So here it has huge. And also the medical domains, and here we have one more data that is 1 and 1. This will be splitted. What it will be splitted? This is U, alpha, and V. U, lambda, and V. So this U, we are converting into this concept document matrix. First one, n number of documents, and R concept. So here we have two concepts. One is medical and another one is computer science. Documents will be, numbers of the documents will be 7. So here we have a 7 rows for the first matrix of the right hand side, and two concepts, that is medical, computer science first one, and another one is a medical. And next one we are calculating that identical matrix. That is, we have this rank is 2, since we have a 2 number of domains or the concept. So this 2 by 2 matrix will be identical matrix will be calculated. And the third one, what is the third one? Terms and concept matrix. The m number of terms and r number of concept. So this weightages, like we have 0.18, 0.36, 0.18. These are all the technical calculations. We have it has calculated by that so and so concept, the TF, IDF, and the eigenvalues for the identical matrix. So just forget about the values. If you look at out the values, you could see in the first matrix, right hand side of the first matrix, 0.18, 0.36, 0.18, 0. Highest value 555 in computer science domain. Likewise, if you come to the medical domain, 0.53 and 0.80 and 0.27, whichever it has the high term, that is 3 and 3 in the left hand side matrix, should have the high weightages, that is 0.80. So this is in the right hand side. If you calculate this strength, so this 0.36 and 0.90 will be highest. In this medical concept, 0.80 will be highest. That will be considered. And this here in the right hand side term concept similarity matrix. So the data will have the 0.58, 0.58, 0.58. This first data will be given as a result. In the medical domain, all this data will have 0.71 and 0.71 will be considered as a medical data. So like this, so these values are reduced, the dimensionality is reduced in the term document matrix, and then the dimensionality reduced with the concept and with the context. Go for the one more example. So here we have a document C1, C2, C3, C4, C5, which is related to the computer. And the concept and the document M1, M2, M3, which is related to the graph theory, mathematical. So first 5 is related to the computer science, and next 3 is related to the mathematics. Same thing, we are preparing the term document matrix. Okay, so here we said we have omitted this A, for, of, other, all those things. So we have a terms like human, interface, computer, user, system, response, time, EPS, survey, trees, graph, and minus. So this, if you take the document value, if you take the first document, that is C1, just we are trying to compare the similarity between two different terms. See, as per the only the document term matrix, if you find out the similarity between the human and user. So if you take the human and user for the document C1, the human is there and similar user would not be there. So the similarity will be given as 0. So it says that there is no similarity between human and user by looking at only this document term matrix. At the same time, users and minus, there will not be any similarity. Yes, it shares users and minus, then the graph representations and user and human related to the computer science, computer related. So it says that there is no similarity. But how could we assure? So again, we are applying this SVD technique. See, these are all the mathematical calculations for this term document. See, we have gone through this for only two different domains. So here we have calculated U value and we have alpha values, that is alpha values, and we have calculated these three simple term matrix which has the additional weightages with the dimensionality reductions with the identical matrix. We are based on this value, if we are assigning this value into this data. So now see, we could see many number of zeros here. So blindly we can say that these zeros we don't have any similarity or we don't have any relations, but the calculations of SVD we could find out the positive relations and also the negative relations. The positive relations in the sense it has the closest similarity. In the negative relations it doesn't have any closest similarity, except one or two it doesn't have any zero value. So we have calculated the weightage based on this SVD calculation. So after this SVD calculations, so we look it out the similarity. If you take the human 0.32 for the document C1, and if you take the user 0.178, so the similarity will be just the similarity. We have a highest similarity, that is 0.89. So if you look it out in this, before we are applying this SVD, it doesn't have, because we are assigned the values based on the occurrence. But based on this SVD calculation, singular value decompositions, additional weightages as applied, and then we could find out the exact. And also the similarity between user and minor, it is minus 0.27. So there is no similarity between user and minus. Likewise, in all search engines, the terms, whatever we are typing it has been applied and it will get the result for the users. And so up to this, we have explained and we have seen this information retrieval based on the user side. Okay, as a user, if I give the data or if I give the term, then how it will be calculated, how to find out that in what context or in what meaning the user is typing. But still, this LSI has the problem with the polysemy. What is polysemy? That the single word which gives a different meaning, but still they are working on it. But it can handle easily, it can handle the synonymy, that is two different words giving a same meaning, but it can't handle properly or the completely with the polysemy. That means a single word apple will give you apple company and also the apple tree. Center, which is a center point, and also the one particular place, that is the center place. So like this, in a single word gives two different meanings, still we couldn't finish. That's why we have seen in this result, when we are typing apple, first we are getting, but as a user, as a father, as a user, just I open the system, I want to show that apple. So just as I don't know that I have to type that apple fruit or fruit apple. Simply I feel that I don't know about the Apple Corporation and the things and all. Just as a father, I know how to handle the system. Then if I type the Apple only, so it comes the Apple company first. And so if you type in the web pages or links, it will display the Apple company first. And third or fourth link only will give you Apple tree or the Apple fruit. So that is also couldn't handle, or that is not completely handled by this latent semantic indexing. And one more thing, the another end. I don't think so it would be related to this, but I could say, I could tell you, I could cover that also. On the another end, if the people are trying to host a web page, or if the people are trying to post like a YouTube channel or web pages or websites or any blogs, or if they are trying to host their content into the internet, at the same time they want to show the content on top. Okay, they want to show the content on top. For example, I'm running an automobile industry. I'm running an automobile industry, a small automobile industry, or I'm doing an automobile agency. So I'm trying to create a web page. So I'm trying to create a web page. I created the web page. And also whenever they are typing automobile, so I expect my web page should come as a top. So what we have to do there also, I have to find out the term. What are the terms which is available in that my web pages? So I have to frame the term. Or to frame the term in my web page, I have to use this LSI. Why? I have to find out the most frequent term used related to the LSI, and also what are all the searches are done. So if you go through the Google, yes. So this could be a proper result, right? So the umbrella in photography, and also this people also ask. So if I created a web page, so just I'm touching this optimization also, SEO also. So if I'm creating a web page related to this photography, so and I have to show what are all the facilities I have, and it gives you the recommendation that the people may also ask, how do you use a photography umbrella? So in my web page, I have to give the content for related to this also. Is a softbox or umbrella, which is a better? How do you make a light umbrella for a photography? So I have to add the content related to this also in my web page. Then only it comes as a top. See, shutter muse comes as a top one. And I have to consider this also. This also. See, umbrella photo shoot, a photography umbrella price, photography umbrella kit, different types of photography umbrella, and umbrella photography ideas, how to use umbrella lights in photography. So if these content, and this content, if I cover this content and I use that content in my website or in my web page, then my website or web page will be given as a high rank. So to do this one, I'm using, or the people using LSI techniques. So just I tell, express this applications of this LSI. So it is used in robotics also. See, you could see in this one of this movie that is switch on the TV. The hero's mother will say, "TV podu," and then simply he'll throw. So the context is important. For that, we have to robotics to the robot. We have to tell switch on the TV. So to understand the context, it is used in the natural language processing (NLP) also. So there are many domains are available. So this LSI mainly, as we have undergone this FDP, it is used in information retrieval and information discovery and automated document classifications. When we are doing, and we have a huge number of documents, and we are so as a user, as a eminent officer, just I want to know the important news which is available in the newspaper. As a famous doctor, one lung, as a famous what is this numerologist, just we want to know the news, medical news related to the numerology in the specific website or in the specific newspaper portal. So it will automatically classify the document. To classify the document, we are using this LSI. And text summarization, just now we explained, this will be used in the web pages and all. So to find out the relationship, so to find if we are giving a more number of documents or the terms, to give the relationship, we are using this LSI. And automatic generation of link charts of the individual organizations. We are giving only the some set of values, connect the relationship among the values, and it will prepare. So this mainly used in the business domain. Matching a technical purpose in grants with the reviewers. So in this reviewers, if they are applying for the grant, so the related, it is used in all funding forums. So to relate the related technical purpose, which is related to the grant which has applied, then based on that technical purpose, the reviewers go through it and they will find out the technical aspect of the grant applied. So online customer support, we have a chatbot and many things we have it. And also we have an online text support to understand that online customer support. We are using this LSI. And document authorship. This is also used in academic domain and to know the ownerships of the specific document. So why? Because it will search in all others, like we could say this plagiarism simply in journal paper. So it will search all other domains. So if anything is not there, which is there in the not there in the net, then it will give you the authorships. So the automatic keywords annotations of the image. So if you text the image or if you give the image, so it will find the keywords based on that image. So it will find out, it will try to understand that it is one of the research work is going on. So by understanding, by looking at the image itself, it will give you the text or the paragraph related to that image, what it says, and understanding the source code. In the IT domain, the people are good at technical wise, and the top mode manager and the other people, they give you the idea to implement the code, but they don't know the technical stuff of the code. To understand that code, it will find out the meaning and syntax of each source code, and it will give you the overall concept. And filtering a spam in images and mail by looking out the keywords available in that mail content. And information visualization, if you are giving a value, it will give you the graphical representation of the data. Essay scoring, literature based discovery, stock returns predictions. It is again one of the very good and big domain used in this stock market trading field. And dream content analysis is used in psychology. If they are having a dream, so we know that the dream, most of the dreams, it doesn't have a proper meaning. So if we explain as in a psychological things, in a psychology domain, they explain about the dream, their thinking and their thoughts. Based on that thoughts, it will find out the relations. That's why I told in the major in med, it is used as one of the field. This LSI semantic indexing is used in the medical domain. What is a challenge? Since it is used, it handles the more number of data, and also it has to find out the calculations. It requires the computational performance to be huge, and also to store or to calculate or to work with the data, it requires more number of memory. So this would be, but nowadays we have a equivalent support for whoever the data and the information grows at the same level, at the same config, we have a equivalent setup at GPU, TPU, and the computational performance, and also the high value. That's it for my session. I hope my motive is just to give when we are typing on how our information is retrieved, when we are typing with the context, and how our information is retrieved, what is happening in any information portal, and how it will be retrieved. And when we are typing a keyword, when we are giving a simple keyword, what are all the background process are going on, how this is assigned, how the data and the terms will be embedded with the relations or the synonyms with the terms. So this has to be understood by the user as a simple common user, not only the computer science background or not only the library science background, and any common users, if they are working at the simple term or trying to retrieve some of the information or the data from the system, then these are all the techniques or these are all the things will be used. So this is the major part of this latent semantic indexing of this seminar. That's it. If you have any queries and clarifications, you can raise.
Any clarification from participant side? Please, you raise your question or doubt. We have much of time to have a discussion with the resource person. We have a good opportunity to clarify our doubts and clarify on everything. Okay. Professor Vinoth Kumar, sir. Sir.
Yes, sir. Yes, sir.
Yes, sir. Speaking, sir. Yes, sir. Sir, Professor Vinoth Kumar, sir.
Tell me, sir.
Yes, sir. Sir, actually, your explanation about synonymous syntax and how to you have shown the keyword such as like food. If you're
Yes.
typing food in Google, it will display the food items are displaying, variety of food
Yes.
available.
Yes.
But similarly, and if you're typing apple, but it's not a
Yes.
came similarly. So who is the responsibility in the displaying the kitty word by keywords?
No,
Whether
it's
in our
not a.
side,
That's why, sir, I told. See, compare with this apple tree or the context related to the apple. If you take this, it comes with the agriculture and the horticulture related things. Compare with the data. The data will be available in the web if you take around 15%, 1.5. But at the same time, we have an Apple company. It is world dominating and leading company. The data will be huge. The data related and high rank, they are doing a research also in this. That's why I covered at last. That means if you are giving any term, then we have to apply this LSI before we are adding this term into the website or whatever we are loading it into the website. We have to apply this techniques. So the if I type this apple, so simply if I type this apple, they applied this NLIC technique for this. Apple means the Apple corporation or the Apple company, there's Apple Mac OS or the tablet, like that, they are applying this keyword. Whereas in agriculture domain or related to this one, we don't have the much capability to compete with that kind of a word. Obviously, in IT domain, the people who very rare to search the tree apple instead of that apple company, sorry, to search the Apple corporation the data at the Apple company instead of searching an apple fruit. So this could see that, but anyhow, user is a user only, but still it is. Say if I type the fish food, so to get actually the fish food, and now there I have to type the fish recipe. So if I type instead of that fish food, if I type the fish recipe over there, if you go images, I will get all this related recipe. So this is the main thing. If you take a simple tree, apple, or the fruit, we don't have that much information on the web compared with the company information. Hello, sir.
yes, sir.
I hope I'm clear.
Yeah, no problem, sir. And sir, one more question from Professor Kavita Anand.
Yes, sir.
What software can be used for LIS?
See, this is LSI is a simple technique only. Even we can use the Python. There are built-in SQL and tool is there in Python. There are built-in libraries. It is very feasible and compatible to implement this LSI and also this semantic analysis. I've shown you this calculation. No? This is done by the Python only. This calculations and this graph and this calculation, this SVD is built in. It has a built-in library in the Python, so we can use Python will be a very good supporting tool to implement this LSI. Any other queries?
Yes, sir. Actually, one more question, sir. Please, sir.
Yes, sir.
Actually, sir, semantic index is representing as a natural language or artificial language, sir?
No, sir. This is artificial intelligence.
Okay.
Artificial intelligence, natural language processing is a domain. So under this artificial intelligence era, it is like umbrella. Our natural language processing comes under this artificial intelligence. So in this natural language processing, we are using this natural language processing in robotics. That is one of the applications of this natural language processing. Natural language processing in the sense like human to human we are communicating right now. So like the data, communication data has to be handled by the machines also. As a human, by the training or by the number of words we are learning in our real life, We are getting all the informations and we are communicating with the context and we are communicating with the actual meaning, but we can't communicate with the system like that. So to make the system to understand the common languages as everyone understand, we are using this natural language processing. This natural language processing, we are taking LSA also one of the techniques. Software.
So, just a small query from me, like it's just a doubt. Like,
Yes.
can we do predictions also in this? Like, I just felt like medical records and everything can be retrieved from this. But if suppose we want to understand, like, what will be the next move of the patient? Suppose the patient wants to go for a higher treatment on this, and can the
So by
doctor do
using
some?
no. By using only this LSI, we can't predict. The thing is, it will gives you the simplified data. It will simplify your queries and what all the queries you are typing based on the information available. So it will create an index. That is a semantic indexing. It will create an index with a relation, whatever the data term you are typing. It won't do analysis. So the analysis we have to do PCA and we have to add the machine learning tool with this data.
Okay, sir. Got it. Thank you.
Yes. Yes.
Yeah, any question from audience participant, please? We have much of time because we have to analyze the current situation, whether it is suitable or not. But Professor given wonderful explanation of the semantic index. So each and every field we have to apply, we have to adapt. So that I'm asking any doubt and to be clarified.
So not only from this presentations and further related to this, if you have any clarification, and you can mail me. This is my gmail@gmail.com. In future, if you need any clarifications or if you need any support, you can mail me.
So in other in what sales applications these are used? So in service industries, like for example in medical, it is very much useful. Like same wise, can we use it in banking and other sectors, sir?
Yes. The thing is, we have huge number of data. In the huge number of data, we are trying to retrieve some set of information. That information, we are not simply taking the information as a raw data. We wish to find out the relation and also we wish to find out the real context of the text, the term, whatever we are trying to retrieve. Wherever this is applicable, we can use this as a method.
Sir, can you please elaborate me real context in a sense? Sorry, I'm asking you in deep, but I could not get that.
Yes, I will come to you. See, this if you take these applications, if you take information discovery, it covers all other things.
Okay.
Discovery and all online customer support, it covers. As you said, in banking sector, just we can apply a basic machine learning tool, a classification tools to find out the relationship among the customer details. Okay. At the same time, if you are retrieving it, if you are trying to retrieve the data, analysis is different as the previous question.
Yeah.
Retrieving is different. Just if you are retrieving the data based on the data terms is available. See, we have in banking sector, we wish to know the people who are all eligible or who are all in favor of taking a housing loan or home loan.
Yeah.
Okay, so we can extract. So these basic kind of analysis that can be used in a semantic indexing also. So we can extract the details if the customers or the bank employer, bank customers details is available. No? So based on the keyword and the terms we are giving to that one. So this SVD gives you the details also, but it gives you the basic details only. In addition with that, you have to add any one machine learning like a decision tree or any other classification techniques to find out to extend the further analysis. It will give you the data only. It will retrieve the data from the huge number of informations. It will retrieve and it will try to give you the clear data.
Okay. Yes.
Good morning, sir.
Good morning, sir.
This is Madhukar Saxena. The small question is that is it somehow like SQL or it is somehow different from that? And
No.
what is the advantage of using this thing instead of SQL?
See, the thing is, now initially the same operation has done by the SQL also. When we have a limited set of information, limited set of data, when we are handling it, if the data is unscalable or we have only limited data, that's it. The data will not be expand and the data will not be increased. Then that time we have been used to that SQL related tools only for querying or getting informations. But in an environment that the data is dynamic and in future the data will be updated, and the data will be increased. So if we are using a dynamic set of data, in the sense, today the data will be this number of sites. For example, is 1 million T. It goes to increased. So the relation among the increased data also will be varied. So it will be increased dynamically. So in that concern, we cannot apply the simple SQL queries because the limitation and the dimension also will be huge and the operational things also will be huge. So we are moving from the SQL queries into this indexing method. The indexing is we are rearranging the data based on the huge number of dimensionality growth. If the data if we have only the similar set of data, that's it. This data is closed. If we have any other data, so this with this data only we are getting or retrieving the information, then we can use the same things. Queries one.
Okay, sir.
But if the data is dynamic, if you are taking a web page, and by day, per day, nearly 15% of the data is getting updated every day. So now we are handling the main fuel as a data only. So if the data is dynamic, we are handling with the dynamic data, then we have to index the data based on our requirements. So for that indexing and the retrieving, we are using this kind of a technique.
Right, sir. Thank you, sir. Thank you very much.
Right. Thank you. In future, yes, sir.
So, Professor, sir, I have one more doubt, sir.
Yes, sir.
Actually, we are searching in Google by keyword.
Yes.
But millions documents are displaying. So I have to consider whether it's right or not. Where do you have any code techniques for applying for getting right documents?
Yes, sir. It is there. It is called search engine optimization. SEO. It will take another session if you start this one. But that's why in all reputed companies, that's why you see we have seen top 5 search engine tools. All other search engine tools other than the Google, they doesn't have more than 10% of the share. Google owns nearly 90%, 90 plus percentage of the search engine shares. Why? Because nowadays all the techniques, since they are covering with website development and managing www and web page Chrome and browsers, all these things they are covering it. They have from the Google Research Lab, they have implemented all those ideas. So the people who are designing the website, anyhow, if you are typing any keyword, that you will get it from the website only. Any one web page which is available in the internet, which is connected in the internet. So the people also this blindly followed the rules and the techniques is implemented by the Google. So there are some people to say that LSI is latent semantic indexing is not necessary for designing a web pages and all. Some people still, if you take on Chinese and Russian countries, they won't agree with this LSI techniques. Why? Because their searching strategies not to that level, not to find out that searching techniques and all. So this LSI technique itself gives you a major role, as you said, to type. If I want to type, I'm typing a keyword. Only I need only the expected result, what I expect. Then for that, we have to give a proper keyword. That is a search engine optimization is there. So if you understand a little bit about that background, then easily we'll get what exactly we want. And also, adding one more point, Google search engine is a common or the commercial search engine platform. See, Google company itself, they are providing many other application search engine tools also. If I want to search my academic journals paper or the conference related thing or journal related things, Google company itself, they are providing Google Scholar. Okay, so if I want the clear data, then I have to use that one only, Google Scholar only. But if I am sitting here and Google commercial search engine tool and trying to get one specific particular data, it may not be happen at all time. Hello, sir.
Thank you, sir. Thank you. Thank you.
Yes, sir.
Excellent presentations and excellent interaction. Thank you for coming and thank you taking your lessons for us. Really wonderful session, I think so.
Thank you, sir.
And dear audience, dear participant, I have given the session attendance some feedback. Please copy and paste and send it immediately. And except 2:30, actually afternoon session, we have a small assessment test will be there. So all the participants requested to kindly cooperate. So then only you can get the course certificate. In which you are failing, definitely you cannot get it back. So kindly understand, this is a important message to you. Please keep in mind, don't forget. Okay, thank you. And
so at this time, I convey my sincere thanks to all participants and the coordinators and the library people from the library department and the principal and the coordinators of this MEPCO Engineering College. Once again, I convey my sincere thanks. Thank you all, friends.
Thank you for your support, sir.
Thank you, sir. Thank you all. Thanks for your the opportunity given to share some of the things with the valuable audience. Thank you. Thank you all.
Thank you very much.
Thank you, sir.
Dr. Muniswaran, sir. Dr. Muniswaran, sir. Professor.
Never stop believing in hope, because miracles happen every day. Good afternoon to all. On behalf of ATL, MEPCO management and personal behalf, it is our great pleasure in welcoming the honorable session speaker, Dr. Devi Mahalakshmi, professor in MEPCO Engineering College, Tamil Nadu. Before this session, she served as a different destination at the different premier institutions. Madam has published over 118 research papers in international and national journals and conferences. She was invited a keynote speaker in more than 17 international conferences across India so far. Professor has had very excellent conferences, particularly in AICTE sponsor, FEP, STTP, and the technical workshop that remarkably speaking was. With this brief introduction, we would like to hand over the session to Dr. Devi Mahalakshmi. Let's welcome, Madam.
Thank you, Ma. Thank you for your introduction. Dear professors, good morning to you all. Am I audible?
Yes, madam. Please.
Yes, sir.
Yeah. It's audible and visible. Everything is clear.
First of all, I express my gratitude to our college management, principal, Dr. S. Arivalagan, sir, convener, Dr. K. Muniswaran, senior professor and head, Department of CSE, and the coordinator, Mr. R. Jabastian, librarian, MEPCO Engineering College, for giving me this wonderful opportunity. I'm happy to take part in this ATL sponsored 1 week FTP on Management Information System. Thank you, sir. I thank the convener and the coordinator for giving me this opportunity. Thank you, sir. Shall we start the session now? Sebastian, sir.
Yes, madam.
Shall we start the session?
Yeah. You can proceed.
Okay.
No problem.
The presentation is it visible to you, participants?
Yes,
Dear participants? Yes.
Yeah.
So the topic I am going to cover today is recommender system for information retrieval, right? So normally in our day-to-day life, we have a lot of questions and lot of decision to be taken, right? So which digital camera should I buy, or which mobile phone I can buy, or the best place to visit during summer vacation, or else the best universities, best institutions, or which movie should I rent, right? Or which website I have to refer regarding one particular topic or one particular domain, etc. So our recommender system will provide answer for all such questions, and it will make the users or the customers to take the best decision efficiently, right? So today for this session, the agenda it covers introduction and purpose of using recommender system and the different paradigms of recommender system. It talks about the technique being used, then other recommender systems, recently evolved recommender system, then some of the research topics which can be exploited further, right? So first we need to know what is information retrieval system. So around thousands of years we are following this retrieval system, information retrieval system. In older days, in earlier days, people will retrieve information using some voice messages, that is one-to-one communication, right? So in earlier stage itself, the recommendation, that is information retrieval system starts, because we communicate with our neighbors and we communicate with others and we try to retrieve the information what are all required for us or the information relevant to our purpose. So that is where the information retrieval system starts. So the information retrieval system will obtain information relevant to the user's need. Then what is information filtering system? The information filtering system, it will collect the information based on the user profile, based on the user interest and all. It will collect the information and present them. The that is top ranked items or top ranked products will be recommended to the user. And sometimes the user may not know, in the information filtering system, the user may not know the existence of that particular products or that item, etc. Right? Now both information retrieval and information filtering fields, they cope with enormous amount of information. So the information or the data may be the user given feedback, or else the search patterns, or else it is something like the click patterns in one particular session. And all those informations are processed both in information and retrieval and filtering, right? And it provides relevant information to the users. That is our main objective. So instead of populating all unnecessary or all informations, it is going to search or it is going to select only those relevant information to the user. It provides relevant information. That is the main aspect. Then it offers personalization, even for a single individual, even for each and every customer. It is going to provide recommendation or it is going to provide information based on his requirement or his profile, right? So normally information retrieval is finding materials. Usually it is text. We are going to access unstructured data. Usually it will be in the text format that will satisfy the need of the particular user or a group of users, and it will be selected from large collection of information. Normally that information is already stored informations, right? So actually it is going to use the static data, and it focuses on indexing and retrieval of textual informations. And the main concern here is it will retrieve relevant documents. And second concern is it is going to retrieve a large of, that is lot and lot of informations or documents efficiently. So it is aiming for fast retrieval. So no one is going to wait in front of the machine for the information to be populated. Okay. So it is, first concern is relevant documents based on the user given query. And the second concern is fast retrieval of the relevant document. So the information retrieval system we all know, right? The IR system will receive the query from the user. So the user, based on his need, he is going to put the query and it will be processed by the search engine IR system, and it will retrieve the information, maybe the documents or text information or images, etc., from this collection, and the list of those items retrieved will be listed to the user. Again, in the listing also, they will follow some ranking. So the most relevant item, then followed by the less relevant item. Like that, it is going to provide the list of items. So one example is our Google search engine. So in the information retrieval system, the main objective is it is going to retrieve documents relevant to the user's information need. So the user is going to provide something like a query. Usually we type some keywords in the Google search. Like that, the user will specify the query, and the system used is search engines. And what is the input for this search engine is the user given query. That is the input which is explicitly given, right? Say for example, in Google search engine, suppose I am typing the query, I am typing a text, COVID-19 prevention. Then you will get lot and lot of informations, relevant informations related to whatever the query you are typing, right? Is it visible to you? Can you see this?
Yes. Yes,
So
yes,
in
yes,
the
yes.
listing itself, it will show all the informations based on the ranking. So most relevant item first and so on, right? But here one of the disadvantages, you will get lot and lot of information when we are using information retrieval system as it is. So the user may get confused which site to be followed or which document to be used, right? So actually it is a, even if you are using search engine, it is a time consuming job, right? To pick the appropriate or the opt information. So now we are comparing information retrieval system with the information filtering system. So in information retrieval system, the output will be what we have seen now. Some pseudo relevance feedback. Somehow it is relevant information only. It may not be the opt one. It may not be the data what you are searching for, what you are looking for. So it provides pseudo relevance feedback. But information filtering, it will, the objective is select the relevant items based on the user interest, based on the user interest, based on the past history or profile of the user. The information will be retrieved from information stream. It may be some static data, may not be a static information. So it consider all the information. Suppose today I am searching for, that is today by 10 o'clock I am searching for one product. Then afterwards, once again I am going to that particular site, means immediately you will get the items related to that item what I am searching, right? So it is using, it is extracting relevant items from the information stream. Even the real-time data is incorporated in this. The systems being used are spam filters and the recommender system. Here the input for this system is implicit data. So the we follow one particular route. We select one item, then we see the items, then we move to another web page and so on. So the recommender system is going to provide some, apart from your normal travel through the website, it is going to provide some additional thing so that the user travel through the website may be changed after seeing the recommended list of items. It may be changed. So some users, they may think it is some interruptions, or they will get irritated and so on. So the main objective of the recommender system is to provide meaningful recommendation for the particular users based on their interest. So it is useful alternative for the search engines or search algorithms. Sometimes it will help the users to discover items they might not have found otherwise. So while searching for some items, by chance you will get some recommendation, and the user or the customer may not know that particular item. So the recommender system, sometimes it will recommend the items, it will help the users to discover new items. Then applications where it is being used. So it is used in almost all commercial, online applications. Then in earlier days, it is being introduced to generate the playlist for video or music services only, and product recommenders for online stores, and content recommendation for social media platforms. That is, suppose you are searching for some literature or some journal paper. Once you type the topic, it will show some relevant topics. It will give some relevant other relevant journal papers or magazines, which will be useful to you, right? And used to explore research articles, experts, or financial collaborators, etc. So these are all the applications where the recommender system is being used. Participants, is it okay for you? Shall we move to the next slide?
Yeah, madam. Please move it is full screen.
Yes, ma'am.
Okay. If you have any queries, you can interrupt me. Okay. So now the recommendation system will match the users with items if you take it in commercial websites. So it will make the fast retrieval of information, that is the main objective, and this information overload. So if you use ordinary search engine, it will give a lot of information, extra information, but the recommender system will list only the top n recommended items, top n relevant items to the customer or users. So it is used in sales as guidance or advisory, etc. So it is a software agent. RS is a software agent. It is continuously extracting the information from the users. And the purpose of recommender system already we know. In retrieval perspective, it will reduce the search cost. So the searching time and all will be reduced, and user will get correct proposals. Through the recommender system, we will get the opt proposal, and user know in advance what they want. So they can easily pick the correct proposal. Then in recommendation perspective, you may have a long tail of information or long tail of items. So the recommender system guide the customers to take decision or to identify the item from the long tail. Then sometimes the user may not know the existence of that particular item. So through the recommendation system, the user will come to know some new item which will be interested to him. And in prediction perspective, it will predict in what degree users like a particular item, right? So based on the ranking. And in interaction perspective, it will give good feeling. Suppose we are using the search engine through the machine, so it will give some responses or it will give some feedbacks. So it gives good feeling for the users. That is, somebody is guiding behind this system. And it will educate the users about the product. Suppose the customer is new to that particular product or new to that particular domain, then the recommender system will educate him regarding that particular product, and it will convince or persuade the user with by giving explanation why he has to buy that product and all. Right? Then in commercial perspective, it will increase the hit ratio, click-through ratio and all. So it will increase the profit and optimize the sales margin. So almost in all online websites, online commercial websites, they are following the recommender system. So it reduces the information retrieval time, and the information overload is also reduced. So the recommender component will estimate the relevance based on the need or user profile. It will estimate the relevance, and only those things will be given as recommendation list. So it is the scenario of recommender system. And if you see this RS as a function, the input will be the information, lot and lot of informations in almost in all format, textual information or web link, click operations, or the moving pattern from one link to another link or one page to another page. So almost all kind of informations will be represented, and the user models will be represented, which is the input or the function being followed. And using this model, it will evaluate those informations or the data, will process those data. Then the relevance score or something like rank will be provided, and based on the ranking, it will list the top n items. So the outcome of this function will be the relevant score or the ranking of items. And different system designs or paradigms are available in recommender system. First one, based on the availability of exploitable data. Sometimes in some situation, we may not get the user profile or we may not get the user interest, etc. So at that time, one particular recommender system will be followed. Sometimes we will get how lot and lot of user profile, rich user profile, or other user pair users information, feedbacks and all. So based on the availability of data, the particular system will be followed. And the feedback given may be implicit or explicit. And again, based on the type, one particular paradigm will be followed. And another one is in which domain we are going to apply that RS system, recommender system, right? Suppose your application is location-based application. Then we have to go for the mobile-based recommender system. So based on the domain where we are going to apply, we have to choose the appropriate paradigm, right? So mainly we have 4 major recommender systems, sir.
Madam, someone asking doubt. Please wait, please. Yes, sir. Tell me, sir.
Hello.
Hello.
Yes,
Sir, no, can you hear me?
Yeah, Vivek, sir. Please tell me.
Hello.
This is a simple like SDA services, online SDA services. That is using selective dissemination of information services. Similar like we providing online like based on the user queries, their matches. We providing these services to users. Similar like that only recommender system. Is it correct?
Vivek, sir. Sir.
Vivek, sir, please.
Vivek, sir.
Hello.
Yeah, please clearly, sir. Please clearly represent your please.
Okay, and at last I will represent. So this.
Do one thing, sir. Kindly represent your words in the chat box.
So you may type your query in chat window, sir.
You can proceed, madam.
Okay. So we have 4 major paradigm of recommender system. One is collaborative, then content-based, knowledge-based, and hybrid method. The last one is combination of all those things. We use hybrid approach. And apart from this paradigm, initially the recommender system that starts with the personalized recommender system. So in personalized recommender system, that particular user or the customer profile alone. Suppose X is one customer which is accessing a particular website for one product, and based on his or her profile alone, the recommendation system or this model, it will be modeled and it will search for those items which are all relevant to this particular user profile. Suppose the user is one academician, and he is usually searching for one particular domain, or he is usually searching for one particular book. Then based on his profile or history, those items will be listed. Even before he started the searching, it will provide list of items that will be interested to him, right? That is personalized recommendation system. Here no other information will be incorporated. Only that particular user profile past history will be used to make this recommendation list, to provide this recommendation. And here the type of logic followed is, sometimes the buyer or the customer or the user has thin profile, right? Say for example, every time he is searching for different product or different product, in the sense, one day he is searching for book and another day he is searching for some other product which is not relevant to that first item. He is searching for some automobile product, right? Then from his searching history, we cannot make a rich profile. We cannot make a rich profile, or we will not know what is the original interest for that particular user or the customer. So such buyer has a thin profile, or sometimes they may be a new user to that particular website. They may be a new user. For such users, what is the standard logic will be followed. Almost in all websites, once you enter into the website, the most trending items will be listed, or freshly arrived items, or recently reviewed items, or the discounted offered items, items with a discount and all. So in almost in all websites, these items will be recommended in the first page itself. So if it is a new customer, then these things will be recommended to him. So for this recommendation, the technique or the model used may be a simple one. So on that particular day, whatever the trending item available or whatever the freshly arrived item is available, those things will be recommended. Then advanced logic, here the buyer or the customer has a rich profile with a sound history, right? So reason that is, he is buying some frequently he is buying some products related to automobiles, or frequently he is buying products related to books. So based on his behavior or based on his interest, a rich profile will be created. And here we cannot use the simple logic. We cannot use our standard logic of recommendation system. Here we need one sophisticated recommendation algorithm, because we have lot of information regarding that particular user. So it takes meticulous calculations on the history of data, and we need sophisticated recommendations, right? So actually here we need a recommendation engine provider. Say for example, a new customer visited that particular website, first time visitor. Then for the first time visitors, the recommendation engine usually show those things, most trending, latest deal, etc. And if he is a returning visitor, that is some old customer, then suppose recently he bought a road bike, then the recommender system is going to list or going to recommend some related products, right? So it on his arrival, suppose he is an old customer revisiting the website again, then based on his previous buying pattern, based on his previous purchase pattern, the recommendation system will provide some additional maybe some accessories needed for bike, so that he may be interested to buy that particular product, right? Or some seasonal offers. So if he is a old customer and some seasonal offers are weekly deals or daily deals or rating based recommendation. For his profile, some items are ranked, and based on the rating, that is the ranking, it will be listed. Say for example, the last year or the last season, that particular customer reviewed some of the items. He may review some of the products, or he may bought he bought some products in the last or previous year. Then based on his history of data, some seasonal products will be listed. So that is what the personalized recommendation system will do. Say for example, recommended items that they previously viewed and left without buying. So first those items will be listed so that the user may again take the decision on those items now. Then the products they already purchased are added to the cart. Those items will be listed. Or some offer. So the some users here they will use other users purchase pattern. So if that particular product, say for example, if I am buying some bread, then some other related products will also be listed, right? So almost in all websites like Flipkart, Amazon, Walmart, they are following this technique only, personalized recommender system. Here the main thing is only that single user, that particular user profile alone will be used to take the decision, or it is used to provide the ranking for the items, and based on the ranking, top n items will be recommended to the user. And sometimes you can see some pop-up windows. Some pop-up windows will be side by side. Some pop-up windows will be displayed. So here also they will increase the interest of the user. Right? Suppose I am searching for one item X, and relevant to item X, they may recommend this may be interested to you. Like that, one some small pop-up window will be displayed side by side. And here the thing is, the pop-up bouncing rate or the frequency should not irritate the customer. We should not, that is, the pop-up window should not be displayed for every 5 seconds or for every 1 millisecond, etc. So after half an hour or 1 hour searching, if the pop-up window is on, means he will not get irritated, right? So here the main thing is it should not irritate the customer, and the bouncing rate, the periodical, that is the time between two such pop-ups. That is some significant thing here. And it should not block the natural journey of the customer. He is trying to locate one particular item. He is trying to search for one particular item. But the pop-up window should not deviate his searching. It should not deviate from his normal flow. So that is the important thing here. Then apart from these pop-up windows and all, some websites they are following off-site recommendations. They will periodically send emails to recommend one particular product, or to recommend the weekly deals or discount sales, etc. And recommendation through Facebook Messenger. So based on, it is also off-site recommendation. And all these things are only based on the personal profile of the customer. So it comes under personalized recommender system, right? Dear participants, do you have any doubts or clarification?
Madam, actually the question from Professor Uday Kambar. Yes, he actually interact with us. Is the recommended system similar like online, like STA selected?
Yes, the recommended system is similar to STI, but in STI they may type the query. The user they may state what is his preference. But the recommender system, without getting any queries and all, it will use the past history or past behavior of that particular customer or past purchase pattern of that particular customer, and it will provide the recommendation. That is, without our knowledge, we are being tracked whatever the items we are purchasing and in which season we are purchasing that particular item and all. So those informations will be used, and based on that they will provide the recommendation.
Mr. Vivek sir, are you clear?
Sir, is it okay for you? Vivek sir?
Professor Vivek sir, Vivek Kumar, is you okay?
Do you have any queries?
Yeah, madam. Actually,
Yes, sir.
Yes, actually, you are actually totally it's online purchasing product, right?
Yes, sir.
Yeah, it is any recommended system for learning resources. I mean, library and everything.
Sir?
Any resources?
Not able to follow what you are telling, sir. Your voice is breaking.
Yeah, please speak. Actually, you are actually in the recommended system. Is it for online product? Yes.
Yes, sir. Not only for the online products, almost for all search engines. Wherever you are searching for some information, wherever we are trying to retrieve information.
Okay. Yeah, suppose we want some edition of the book. It is where you have to post it and where it is registered.
Yes, sir. Yes, sir.
Yes, that's my question, madam.
Yes, sir. So almost whatever we are typing in the internet, whatever we are giving, whatever the query we are typing, or whatever the word we are typing, all those things will be tracked. All those things will be exploited, and a knowledge base will be, that is, they develop one knowledge base based on the behavior or based on the word we are typing. Everything is internally tracked. From that, they are developing a knowledge base, and that knowledge base only processed. In the recommender system, only the data processing is done on that particular knowledge base, and again they are indexing the knowledge base in such a way that based on the interest or based on the domain, they are indexing the knowledge base. So here also they are following indexing. In the back side, we are following the indexing only. How to use IR system in an engineering college library. Okay. Suppose if you allow that particular user, suppose I am one user in a particular library, normally the library search machine will be, normally we will not provide any user information while searching in the library. Right, sir? While searching in the content page, we will not provide any our personal information. Maybe we will not provide our user ID, etc. Suppose if you permit the users to provide his roll number or user ID, then we may track, right? So normally in college libraries, the user, the search, that particular website will be available. The user will just type what is the title they need or what is the author name they need. But if you allow the students and faculty to provide his roll number or his ID whenever he is searching for a particular item, then we may build the knowledge base. Suppose I am providing, every time when I am searching for one book in the library, I am providing my login ID. Then we may build a profile for that particular ID alone. Or we can build a profile for one particular student alone. So say for example, if he is a ECE student, then we can build a profile for all the ECE students. It will make our searching process easier. Suppose another ECE student log in provide his ID and he is searching for some book, then we can recommend these are all the subjects you can normally you will search for. Like that we can provide. But normally in library search system, the user will not give his ID or roll number. Right, sir? So if you get all those informations, the user ID or branch, which branch that particular student belongs to, then we can build the knowledge base. We can create the profile for every individual students or a cluster of students. We can build a profile, and that profile can be used by our recommendation system. Okay, sir?
Yes, okay, madam. Actually, another question from
the library, in academic library, they might have the database book details and student information. They are maintained separately. Only when the student take one particular book, we get the user ID of that particular student. Right, sir? Only when that particular student is going to get a book from the library, we will get his roll number or ID. If he is simply searching for one particular item or one particular book, we will not get his personal information. We will not get his roll number or other IDs. Like, right, sir?
Yes, you are right. Yes.
Okay. Any other queries? Participants? Okay. Shall we continue with the session? Then the next recommender system is collaborative recommender system. Here, what we will do is, if the particular user bought some items, then we will see similar type of customers, their profile information, their purchase pattern or their behavior will also be incorporated in the recommendation engine. So in addition to that particular customer profile, similar type of customer profile is also being used. And based on that recommendation, sometimes in the website you will get the message, if you buy this, if you like this product, you will also like the other, they will show some other product. If you like this product, you will like this one also. Like that, they will provide recommendation. So that is known as collaborative recommendation system. Here, they are using the peer group data. Suppose this particular user is one EC student profile, one EC student, then we may study the community data, the peer group data, other EC students data. This data is also being used to provide the recommendation. Right? So tell me what's popular among my peers. So other students which are all having the similar kind of taste or the similar kind of domain they belongs to. Right? So that is collaborative filtering recommendation system. Here what they will do is, they generate the recommendation based on the current user's profile as well as other similar users' rating profile. So normally used by almost all commercial e-commerce sites. And here, since we are going to use multiple users' data, we need a sophisticated algorithms to model this recommender system. Almost in all commercial websites, they are using this collaborative filtering. Right? Actually, they are using the wisdom of other crowd, other related crowd. But this idea is based on the assumption every user will provide the ratings. So always they are looking for the feedbacks or ratings once you purchase that particular item. So this collaborative filtering is mainly based on all users' ratings. So they take the assumption every user will provide the ratings, either implicitly or explicitly. And another assumption is the customer who buy that particular product will have similar kind of taste. So if he is buying this particular product in the past, then he will have similar kind of taste as like another peer customer, right? So these are all the approaches being used, mainly memory-based and model-based approach. So in one approach, we are concentrating on the user interest. And another approach, we are concentrating on item, the properties or characteristics of the item. But in both the cases, the nearest neighbor in the sense, the peer group, they must have the similar kind of taste. They must have the similar kind of thirst. So that is the meaning of the nearest neighbor here. So in simple CF approach, normally we use a matrix where we are maintaining every user's ratings for every item. Every user's rating is maintained in a simple matrix-like format. Then we run the prediction algorithms to determine which, for one particular user, whether he will like that item or dislike. So for example, here this matrix consists of the rating given by all the users. So these users are now neighbor users. Neighbor in the sense they are having similar kind of taste. They are having similar kind of profile. Suppose Alice is one academician, then this group of users also belongs to the same domain or the same, they are having similar kind of interest. So we are maintaining all those users rating for every item. Now Alice, he is not yet rated this item 5. He is not yet used or by this item 5. So here what they will do is they will see other users rating for this item. They will see other users rating for this item, and some user may be very similar to Alice. Some users may be from different, they have some dissimilar taste. So only those users who are all having similar taste, those users rating will be incorporated here to provide or to decide recommendation for this person. Okay. So such items are all selected, and it will be listed whenever this person starts searching for some items, such kind of items, because already her interest is similar to this user 1, 2, 3, etc. If they are liking this item, means Alice will also like item 5. That is how that particular product is recommended to her, right? Can you follow this? So that is what collaborative filtering based recommender system, along with the customer profile or user profile, it will consider peer group profile. Who are all having similar kind of taste, similar kind of searching pattern or purchase patterns, etc. Those data will also be used here to recommend one particular item to that particular customer. And now this user-based method is known as memory-based. And here that matrix will be used to do the prediction whether Alice will like item 5 or not. To make that decision or prediction, that matrix rating matrix will be used. But this approach cannot be used for real world commercial applications because we have millions of customers having similar kind of taste, right? Millions of customers, they might have the same behavior pattern, purchase behavior pattern, or similar kind of taste. So we cannot use this approach for real-time applications. So what they will do is they will use model-based approach. So in model-based approach, those matrix data will be pre-processed. So the rating matrix data is pre-processed, and based on that, a model is learned. Then afterwards, at runtime, only that learned model will be used to make decision or to make the prediction. Only that learned model, the learning is based on all users' profile who are all similar to allies, who are all having similar taste as like allies. So once the model is learned, afterwards in runtime, we are going to make prediction using the learned model. So it is not a time-consuming work. But periodically we have to update the model. That is the important thing here, right? Suppose that model is built around 2015, and the taste of the customers or the peer group may be changed after 2 or 3 years. So we have to periodically rebuild the model and retrain the model. That is the important thing here in model-based approach. And this method is known as item-based, also known as item-based approach. So in item-based approach, what they will do is, instead of considering other users' rating, instead of considering other users' rating and all, they will consider the other items similar to other items. So say for example, similarity between item 1 and 4. We are using allies rating. Similar item 1 rating provided is 5, and item 4 it is given as 4. From that we can infer these two items are maybe relevant, and the particular customer is interested on these two products, and now they will decide for item 5. If item 5 is similar to item 1, allies may like this item, right? Or if item 5 is similar to item 4, he may like this item, and that value may be 80%, right? So based on this, they will recommend this item 5 to allies, right? If your item 5 is related to item 1, then they will conclude if item 1 is liked by allies, and she may like item 5. That is how the prediction will be done, right? They will not use the user ratings, they use the product-wise ratings for making the decision. That is the second approach, item-based model. Then we move on to content-based recommender system. Participants, if you have any queries or doubts, you can interrupt me. If you have any queries or clarification, can ask. Otherwise, we continue with our session. Okay. So the next one, content-based recommender system. Here in collaborative filtering or collaborative recommender system, we depends upon, that is the decision or the prediction will be based on other users' ratings, other users' feedback or other users' rating. We will not know what is the original content or what is the particular object or product is. So based on other users or other user ratings or feedback only, we make the prediction. But in content-based recommender system, in addition to other users rating, we will see the properties of the product. Suppose he liked this product, then here we consider the characteristics or properties of the product, and those things also used in the recommendation process. If he likes this product and there is another product which is similar to this, it is similar to this one, maybe color or some other properties and all, so it will be recommended to him. Here the that is the product properties, item properties or other characteristics also. So along with the user profile, we take the product features